Hey everybody, Swarsky here. Let's go ahead and get into a little video just doing a couple more examples of that change of base, just in case you're not 100% comfortable with it and you want to see a few more, or you want to make sure that you're doing it right. So you can do a couple of these with me and just give you about 4 more examples. So first one here that I have is just 4 to the x equals 111. Remember, we can't just punch this in because if we rewrite this as a log base 4, 111 equals x. Remember, it's just the inverse. This is our A value, 111. Here's our B. And remember, if you can't, if you just not offhand, the change of base formula that we would have to use is log A for log B. Going that way. Remember, I had the previous video in there to explain why that works for us. But let's get into that. So remember, I can't just plug this into my calculator because log, when I punch in log to calculator, it's always in base 10. So I have to use this change of base formula that I have. So in this case, it would just be log 111 log 4. And if I punch that in, oops, not that one. So let's go log 111 and log 4. There we go, and I'll go to the nearest hundredth. Well, let's go to just the nearest tenth just for right now because that'll be good enough. So just about 3.4. So remember, what that means is that's the exponential value for that. And if I were to actually push that in, so if I go 3 to the, and let's just go 3.4. I'll be a little off, but I should be close. I should get right around, oh, sorry, not 3, 4. 4 to the 3.4. There we go. So you see I get right around 111. Obviously, it'll be a little bigger because I'm rounding, but that's what we're finding is the exponential value. Okay, let's get another one in here. So let's do just 5 to the x equals 63. These values can be anything. I'm just using non-convenient ones where we have to use our change of base, and it's not so obvious. So on this one, remember, I can convert it, so that means it would be log 5, 63 equals x. So why don't we, if you want, you can pause the video and see if you can get what I'm gonna before I do it. So pause the video, okay? So I should get log 63 log 5, okay? If we punch that in, log 63 and our parentheses log 5, I get, let's just say 2.6. And that's my exponent. That would be, I don't know why I switched screens, but that would be the exponential value that would make that work right around 2.6. Okay. Another one that we can do, let's just put a couple, and I'll change around. So let's make our coefficient here a little bit bigger, x, and then let's make that equal 4. So before you even start this, think about what your exponent has to be. It's going to be a decimal, it has to be smaller than 1 because my end result, my output is going to be smaller. So if I go, it should be log 15, base 15, 4, and I want to know what x is. Again, if you want, pause the video, see if you can get what I got. Okay, so I go log 4, log 15. So let's see what we get for that. So if we punch in log 4 divided by log 15. And again, just like we were saying, we should get something smaller than 1. So we'll say it's right around 0.5. Okay, and again, that's the exponent that I got. Okay, last one, and I'll just make it as kind of weird as I can here. So let's say 2 to the x. Let's put a radical in there. So here, which again would just mean it's log 2 with 7. Go ahead again, pause the video, see if you can do it, and then we'll see what we get. So log root 7, it doesn't matter what that is. We can punch that in and log 2. Okay. So that means I would go log, I gotta hit second, root 7 divided by root log 2. There we go, 1.4. Okay, so hopefully that gives you a little clarity or just a little more relief that you're doing this right and you're on the right track and you're setting stuff up here. Again, any other questions, stop in during office hours. Otherwise, have a great day.